We are heading towards the next topic of this session, which will be delivered by Miss Sukanya Sinha. The topic of our talk is floating in a paradise of elementary particles, musings of a particle physicist. This is also quite an advanced topic, which is particle physics. But I think you candidates are going to enjoy this talk. And one more thing, she's joining us this evening, this afternoon, from Witwatersrand, right?
Yeah, that's right.
Yeah. Welcome to the session, ma'am. The screen is yours.
Yeah, thank you. So I just wanted to know, is the format that I'll have to share my video as well? I mean, I don't mind doing that.
Sorry?
Do I need to share my video as well?
As you wish, as you wish. If it is possible, then it will be fine.
Okay, great. So let me just try and share the screen. Can you see the screen?
Yeah, we can.
Okay, great. So first of all, I'd like to thank the Masterclass organizers for such an amazing initiative because, I mean, honestly, when I was a high school student, I would have appreciated if someone did this for me. So I can understand that this is a brilliant initiative and I applaud them for their effort. So, welcome everyone to today's seminar sessions. I am a particle physicist, or rather, I'm a particle physicist in training right now. So, today I will be discussing with you the procedures and steps of how I am trying to become a particle physicist and how you can also, if you actually want to. So, moving on, who am I? So, I'm Sukanya. I'm a PhD student at the University of Witwatersrand in South Africa. So, here's a glimpse of my university Great Hall over here. But apart from that, I'm a member of the Atlas experiment, which is based at CERN in Geneva, Switzerland. I'm sure a lot of you have heard of this experimental lab because it is the home of the Large Hadron Collider. So, if some of you don't know what the Large Hadron Collider is, it is basically the most powerful and the largest particle accelerator designed by mankind. So what you see over here is the circumference of the tunnel inside which this Large Hadron Collider exists. The circumference of this tunnel is roughly 27 kilometers, so it's huge. And the fun fact is, this tunnel is actually dug underground across the borders of Switzerland and France. So my experiment is on here, on the left-hand side of the picture. And right from here, when you want to reach this position, you're basically crossing over from Switzerland to France. So you can just walk past this position and you will be in France instead of Switzerland. So this is like an amazing experiment, which is active right now and collecting tons of data. But before I go into that, I assume you, or most of you are like class 12 students, or maybe you have just passed your 12th. So you know that there is something called physics. There's a subject called physics, but you do not know what are the different topics or fields in physics which you can explore. So over here, I have a cartoon on the right-hand side. What you see here is the 4 different classifications of physics, broad classifications, I must tell you. You all have heard of classical mechanics. Some of you have heard of quantum mechanics, probably when you were studying atoms and nuclei in your 12th syllabus. And then maybe a few of you have heard of relativistic mechanics, which is kind of something we are introduced to in our earlier classes by Einstein's equivalence principle, E equals mc square. And the last one over here, quantum field theory, this is something extremely elaborate and not in the domain of 12th standard students at all. But the reason why I have this picture is because I want you to appreciate the different classes of physics. Classical mechanics usually deals with objects that we can see in our daily life. So you see here a cyclist, you can see a cyclist, and the motion of a cycle is governed by classical mechanics. Now, quantum mechanics is dependent on something which we can't see with our bare eyes, but we know it exists. So anything which has the size of less than, let's say, 10 to the power minus 9 meters, quantum mechanics governs this. Finally, relativistic mechanics means that super high speeds comparable to the speed of light, but they are large enough that we can observe them in astrophysical scenarios. So I'm talking about planets, I'm talking about galaxies, I'm talking about nebula, black hole. Those are governed by relativistic mechanics. And finally, quantum field theory. It's the study of the smallest and the fastest things. So over here, I have color coded the different fields of physics. Different fields of physics based on the speed and the size of the constituent kind of particles that we're discussing. So what do? I work on particle physics. Now, as I said, particle physics is the study of the most fundamental constituents, which we kind of feel, but we do not see with our naked eyes. So it is the basis of everything in the entire universe. Now, to have an idea of how small things are in the particle physics level, you can look at the kind of diagram I have on the right-hand side. So you have the universe, which is the biggest thing known to mankind right now. Then you condense to the solar system, which is a bit smaller than the universe in total, but it's still big enough. Then you come to the Earth level, which is like smaller than the solar system and the universe, obviously. And inside the Earth, you are present, you as a human being. Now, you as a human being are made up of DNA molecules. But DNA molecules are also made up of some particles. That is the field that I'm working on, particles which make up everything that we see or experience. So, what is the basis of particle physics? Now, I'm sure you have learned a bit of atoms and nuclei. You have probably heard of the de Broglie wave and particle nature. But particle physics says that everything that we experience, everything that we see, is made up of particles which constitute the standard model. So there are different particles which constitute the standard model. And I won't get into these details because this is a bit complicated for your level, but it's just there to give you an overview. So I'm sure you know few of these. You know the electron, and you probably have heard of the most recent discovery of the Higgs boson, which was discovered in 2012 at the Large Hadron Collider at CERN by my experiment and another associated experiment called the CMS experiment. But the issue is that even though we have discovered so many particles and we say that we understand the intricate mechanisms that are happening in nature, we still do not have all the answers. So you might ask, what are the questions that are still lurking in this field of particle physics? So there are several open mysteries of the universe. What is dark matter? What is time? Why is time always moving ahead? Why can't we go back in time? That is time travel. Also, there is a question, are we actually the only living beings in the universe? Or is there some other species out there as well? Then the next question is, I don't know if you have heard of something called cosmic rays. So they come from outer space into the Earth. So the question is, why do cosmic rays behave as they do? And there are several other different questions in particle physics, but the most interesting question, which kind of intrigued my interest, is this pie chart over here. So what you see in this pie chart is a distribution or an idea. So according to this pie chart, it is said that roughly 5% of the whole matter or energy is what we call the observable universe. So, I mean, it is a bit difficult to understand this, but let's use this example. Suppose you have a coffee cup and you want to kind of fill the cup with a lot of coffee, but it's late at night and you don't want to stay awake the whole night. So you fill 1/4 of the cup with coffee. So then, this 1/4 of the cup with coffee, or less than that, is what you, I, everything in this whole universe is made up of. But what happens to the rest of the cup? Is it empty? No. According to physics, there is something called dark matter and dark energy, which constitutes 95% of the entire matter and energy constituents of the universe. But we do not know what that is. So I am searching for dark matter in the Atlas experiment by the data recorded from the LHC. So yeah, let's take a step back. I'm doing that right now. But how did I get there? So this is an interesting anecdote I'd like to share with you all. So what you see on the right-hand side of this slide is an animation which is showing the discovery of the Higgs boson, which was done in 2012. So I was a student in 2012, just like you. I was in my class 12, and that was when the Higgs boson discovery was done. And I didn't know anything about it. But I was like, wow, what is this thing that people are discussing and why is it so fascinating? And then I dug through some newspaper articles and I read, because honestly speaking, that time we didn't have so much high-speed data, neither did we have geo unlimited internet that we could just Google easily. So I had to go to a cyber cafe and check out that what's this big deal all about. And then I found out that scientists found a new particle which is supposed to give mass to all other particles that you see. So it is kind of a particle which imparts mass to everything else. And the cartoon over here shows a scientist who is digging through a haystack. And if you probably can't see it, but he's raising his hand and pointing a needle. So he said, we found the Higgs boson. And it was basically like finding a needle out of a haystack. So it's a very, very, very difficult and challenging task. And it literally took them like, I don't know, 50 years since the suggestion of this particle to find it. So 50 years is a long time. But that got me thinking. Now, this is something really fascinating, and I was kind of inclined towards physics by then. So I thought that why not take this as a career? But yeah, it is interesting, but it is challenging as well. So we need to look into the details of how to get into a career of particle physics. So the first step is, if you want to understand a subject, you need to have in-depth knowledge of that subject. And honestly speaking, nowadays, even if you have in-depth knowledge of a substance and you do not have a degree in the relevant subject, then it's probably of not much use. So the first step is get a bachelor's degree, and it should be preferably with honors in physics. Now, I was asked to chalk out a kind of price plan for the different stages of education. So I have this right-hand side column in these slides, which will tell you the price of getting enrolled in a college for that particular level of your education. So usually in the government colleges, I am from Kolkata, so I studied in Calcutta University. Usually in Calcutta University government colleges, the price is roughly 3,000 to 10,000 per year. But if you want to join a private college, there's a disclaimer, it usually costs a fortune. So think about it before you want to join. So the first step is getting a bachelor's degree. And I started off my bachelor's degree in 2013 from Ashutosh College, Calcutta University. So this is a pretty decent photo of our college entrance. It's not usually this empty or this beautiful. So it's definitely an edited photo. So right, I did my BSc with honors in physics from CU. The next step is you need to get a master's degree. So to get a master's degree, you can either get it by clearing the different entrances like IIT JAM or JEST. These are nationwide entrances which can get you into top research institutes in the country. And most of the time, if you clear JEST, you can directly get into a degree where you get your master's as well as a PhD. So it is often called an integrated PhD degree. Fine, but those are super competitive entrances. So I think only, I don't know, maybe 300 or 400 kids get into that every year. So if that's not your cup of tea, what do? You can clear the individual entrance exams for the different universities like Calcutta University, Banaras Hindu University, Jawaharlal Nehru University, Delhi University, even Hyderabad Central University, and several other state level universities as well. And the price of enrollment to these universities are roughly within the range of 3,000 to 5,000 per semester. And if you are enrolling in a university which is away from your own home, then you might need a hostel. So the price of the hostel might be 3,000 to 5,000 per semester, excluding food. Right. So that's the price point for the second option. For the first option, if you get into IITs or any other kind of advanced research institutes, it's roughly 40 to 50,000 per semester, along with hostel and food and tuition fees. So what did I do? I opted for the second option. I started my master's in Banaras Hindu University. God, I miss this place now so much. There's been lovely memories over here. So then after you're joining your master's, what do? You have to choose your specialization courses very wisely. Now, I have listed this over here as a guideline, but I do not expect you to follow these courses or understand what these courses are about right now. But if you want the slides, you can take it in future and access these guidelines. So you need to choose your specialization courses wisely. To become a particle physicist, I believe these 4 courses will help you go a long way. It's definitely helping me. Fine. I finished my master's with specialization in theoretical particle physics, listed the courses in the previous slide. Then finally, the question, how do you get into a PhD program? So in India, there is only one way of getting into a PhD program. It is by either clearing the different entrances I have listed here, which will get you into a proper institute. And the price point of these institutes are listed here. So for IITs and other institutes, it's the same as MSc, 40 to 50,000 per semester. But for abroad, for United States of America, they require you to clear entrances like GRE and TOEFL. So I have listed the price points for GRE and TOEFL over here. And for every other country apart from USA, what matters is how good your scores are, if you have any research experience, and if you have 2 professors who are willing to say, this person is amazing, take them, they will be a good physicist. And the price point of that also depends over here, which I have listed. Right. So what did I do? I joined Wits University in South Africa and started here as a doctoral student last year. And I joined the Atlas experiment because South Africa Wits University was tied to that experiment beforehand. So, what are the pros and cons of being a particle physicist? The pros of being a particle physicist are you get to be a part of something which is amazing. It is a cutting edge research going on right now. You can understand how the nature works if you want to. You get to meet brilliant researchers from all over the world and learn how they came to be where they are now. And finally, being a particle physicist lets you travel the world. I mean, I started my PhD last year and I've already been to 6 countries because I'm working in different places. So yeah, traveling, if you are a fan of traveling, then that's also a plus point. But what's the negative point? So the negative point is research is always challenging because it's not like any other job where you know that there is a definite outcome. You do not know what your research will lead to unless you actually do it. So it is a challenging field, but so if you want, you can go for it if you're really willing to understand what's going on. Now, the final question is what to do after the PhD? Well, there are usually 2 options. There are more, but I'll focus on 2. So, one is if you want to learn more, you can continue in some institute as a postdoctoral fellow. You don't have to think about that right now, none of your business right now, just for your overall information. And once you have learned a lot, you can start looking for teaching positions in different universities or research labs. So, that's the basic idea. And so I would like to conclude my presentation with this takeaway message, which was also in my abstract. If you ever felt that you want to understand something more than what's going on in your specific country or the world, if you want to understand the universe, if you want to know where we came from, how we came to be as we are, and if you want to ever find out what are the intricate mechanisms which govern our day-to-day lives, then probably research in physics is a career for you. But in the end, it's your decision. Thank you.
Thank you so much, ma'am, for presenting this much detailed presentation to our candidates. I must say this was a mind-blowing presentation, and I think you have mostly covered most of the possible aspects of this nuclear physics or physics. But if anyone is having any question, please unmute yourself, or you can type it out in the chat box. Is there anyone who is having any question related to physics or nuclear physics?
Hello.
Yes.
Hi. Hi, Chitradeep. Hi, Sukanya. I am Arnab. Actually, I am a master student. After getting your topic of particle physics, I interested to have a look what's going on there. So I joined. Okay, it's a nice. Before asking my question, I'd say it's a nice talk. Okay, I visited Atlas Library once as a visitor. Okay, that's a nice, and it's nice to have a get to know about what's going on there. It's really good. My question is not related to any this physics. I just want to know that means you joined which university, right?
Yeah,
Okay, as
that's
a
right.
PhD
Yeah.
scholars. Okay, and you
Yeah.
get to work in Atlas. Okay, so is it means how is it your topic, or means how did you get to Atlas after?
So in South Africa specifically, what they do is if they have any PhD positions, they give an ad in Inspire High Energy Physics, and from there, if you think you're good enough to join that PhD position, you can contact the supervisor, and then you go through a whole interview process and selection process. And once that's done, you join the supervisor's team. So I applied for the Atlas particle physics position ad, which was there given in 2018. And yeah, then I got selected for the interview. And that's how I joined Atlas, because the position was meant for a PhD within Atlas. So you have to
Oh,
look for such positions. You can find similar positions in India as well for CMS experiment or Alice experiment as well. So that's how you have to search for the positions.
okay, thank you. Actually, I'm pursuing a master's in computer science, so I don't have that qualification to pursue again in, as a
Yeah,
thesis.
so I mean,
Is there any position for computer science in
yeah,
CERN?
actually there is. So I mean, CERN has this. How do I put it? This program, which is called a program for technical students. There they take either computer science students or engineers, and you can apply for a internship at CERN. And if you are good enough in the internship, there are times when they kind of absorb you as a PhD student within CERN. So there is definitely options for computer science people as well. That's not a problem.
Yeah, thank you, Sukanya.
You're welcome.
Thank you,
All
Mr.
the
Bhadra, for asking this question. Please let you know that Mr. Bhadra is one of the core members of Masterclass. In fact, this workshop was started with his talk on computer science and engineering. Thank you so much, Ms. Sinha, again for joining us and for delivering this beautiful talk to the students. I must say this was mind-blowing, and I think students
Yeah,
benefited from your talk. Thank you so
yeah. I
much.
mean, if you need the slides, I can send it around via Debashrita, or maybe I can send it to the Google meeting email that you had. I mean, it's a very elaborate talk,
Yes,
so I
indeed.
mean, so it's not possible for students to really appreciate everything at this stage. I couldn't even when I was at their level. So yeah, I wish all the students all the best, and I wish you guys all the best for the effort. And I hope there are many more of the master classes in near future. Thanks.
Thank you so much.